Hello friends, in earlier video we started with understanding what is retrieval augmented generation. So in this video we will understand what is vector embedding. Vector embedding is required to create embeddings from the documents, and embeddings are used and stored in vector database for retrieval augmented generation. So let's understand what is chunking, how chunking is done, with different types of chunking, which will go in details later on, and then from those chunkings, how the vector embeddings are created, and what is the purpose of doing it, and storing it into vector database and indexing them for retrieval. So like we understand creating vectors, dot product, vector products in maths. So we had learned a dot in a two-dimensional plane, a line in a three-dimensional plane, and how far and near they are from each other, right? Similarly, in a corpus there will be words as subwords, and how those words are semantically far or near to each other. That is what vector embedding is about. So every word is converted, or a subword is converted into numerical numbers or numerical arrays that are stored and based on context and similarity, right? So like we have language models. Similarly, there are models to generate vector embeddings. So the the two which I have been using or came across are the OpenAI ADA model, which I had used in my one of the assignments, and another is AWS Titan. So OpenAI ADA model supports 1536 dimensions, while AWS Titan in it can be configured. Like the purpose of AWS Titan is for integrated custom apps, while OpenAI ADA is used for similarity search and clustering. Okay, so the solution which I worked on and built using uh, LangChain and LangGraph lighter version, OpenAI LangGraph we had used uh, 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 OpenAI ADA, and the database to store them we were using with Postgres with vector extension, right? The input capacity of it is to more than 8,000 tokens. So to understand difference in how earlier when I started, I had a confusion since I had learned and worked on machine learning AI. So in case of earlier way of doing the document and finding the uh, vectors based, so we had used how far the documents are from each other. We use the term frequency, inverted document frequency. So there every word used to be one dimension, and the number based on the number of counts of each word, how far the vector of a document would be decided. And there also for distance we used cosine similarity to find how each document is far or near. And even the question, suppose example, if we ask a question to a Google would create a word count vector, and then compare that with the other vectors for each document. So in such cases we use cosine similarity because it does not give importance to the magnitude, but to the direction in which the vectors are and how close or far they are from each other, right? So uh, uh, so vectors is about tokenizations and dimensions. So the tokens are the number of words or the subwords, the input which a embedding model can take, and the dimensions are the the kind of slider information for each sentence which it can be to uh, based on which sentence is stored and into the vector information is stored. Like so, dimensions could be any information about attributes, could be something like uh, yeah, we'll come back to it. So yeah, so like let's take the example: a king, queen. A king is a male, female would be queen, and king is a crown. So all these words will be close to each other, even though they are from different gender, but based on semantic similarity, they will be close to each other, right? So once these vectors are stored, how the vector search is done. So whatever question if we ask or the input we give, so even for that a vector is embedding vector is generated, and then the model compares in the database which vectors are close to the vector of the question, and based on the query it will return the top results, and based on which the input can be given to the language model to synthesize the answer, right? So in the real world it is used for semantic search, content recommendation, advanced text analysis. So what is the purpose of using vector embeddings or the vector database? So like any language model is trained for certain date and the period the data it has, and if any question is asked for the information post the model was built, it will not be able to answer, and it will try to hallucinate or give a wrong answer. So in such case, to provide the right context, we use a knowledge base in which data is stored in the form of vector embedding. So we will have separate videos on how different forms of context is used in the agentic solution. So vector database is one way of the context about the domain and the solution. Then the second context is about the user which is interacting with the system. So that would be the chat history or like that. And the third context is the context about the user profile and its demographic data, which is helpful in formulating the correct response for a given user. Yeah. So the mechanics of vector embeddings. Suppose the sentence is the quick brown fox, and if you need to generate a vector embedding, how it would look like. So in English or similar languages, the subword token is there. In some other languages, subword tokens are not there. So accordingly, we need to use different vector embedding models which are suitable for the those languages, words and sentences to be converted into vector embedding, right? So tokenization. So if we understood in English, if subword token is possible, a single word unfriendly can have into 3 token unfriendly, right? So mapping meaning in high dimensional space, as I mentioned earlier. So like king and queen are close to each other, and then king is a man, and when we ask king a man plus woman, it will lead to the word queen, right? So the semantic distance of queen is close to king, man, and woman. So language models goal is for the generation. So like if any question is asked, based on what the question is asked, accordingly it generates the sentence, and while generating sentence it will predict first word, and based on that it will keep on predicting the next word and generate the text or response based on what kind of solution is. While the embedding model option objective is to do the creating the vector embeddings to store into the database and then to do the retrievals from it, and while retrieving it will come again convert those vector embeddings into the words or the sentences, right? So rather vector embedding are more crucial if we are able to retrieve the right data for a given solution. The only work job left for a language model is to correctly synthesize and put the uh, retrieval output in a right way to be shared with the customer. So let's understand AWS Titan versus OpenAI. So AWS Titan is configurable and its size dimension is from 256 to 1024, while ADA is 1536 dimensions, right? So why find 536? Why not more than that? And so it all depends on the combinations of uh, uh, the dimension size, the number of tokens, and the time it takes to generate vector embeddings for that input. Yeah, so accordingly, based on the testing, those algorithms are optimized, and then uh, after thorough testing, that is those values are freezed for given models. Right. So let's understand with the example. Suppose uh, the information saved in the vector embedding is that cats are curious and playful, and if the question asked by the user is how do cats behave, right? So if it is a keyword search, then behave will not be able to map to curious and playful and give the answer, while in case of generative AI agentic solutions where we use vector embeddings, behave will be close to curious and playful, and it will uh, based on the meaning and semantic similarity, curious and playful is a behavioral attribute. So it will be able to find this vector close to the question vector, how do codes behave, and it will be uh, returned back in the results, right? And very this input is then given to the language model to draft the output for the user. So where all we can use vector architecture or vector embedding. So one is used for semantic search. So like if you say I want to arrange a meeting, I want to have a meeting, I need an appointment. So all those are different words, but semantically they all have the same meanings. Clustering, so grouping similar data points automatically for analysis, right? So with the help of vector, similar words are grouped near to each other. And finally, the third is doing the recommendation. So uh, if you buy certain product online, it tries to show you similar other products. So that is a recommendation. Even if you go to any store or a superstore, yeah, we buy certain products, and then accordingly based on what our interest and products we buy, we have the coupons delivered, and so that is what the recommendation is about. So let's understand what are the see how much we understood, and by solving the quiz. The first question: what is the primary purpose of a vector embedding in the context of AI? Here are the four options, and here is the hint. Next question: which of the following describes the key difference between LLMs like GPT and specific embedding models like OpenAI, ADA? Here are the four options, and here is the hint. Next question. What is the fixed output dimensionality of the OpenAI ADA embedding model? Here are the options, and here is the hint. Please pause it and then try to solve these questions and see how much you have understood. If required, revisit the video or let me know in comments what more you want to learn. How does subword tokenization such as word piece handle complex words like unfriendly? Here are the options, and here is the hint. What mathematical method is typically used to find similar vectors within a vector database? Here are the options, and here is the hint. Next question. Which of the following is a distinguished feature of AWS Titan embeddings compared to OpenAI ADA? Here is the options, and here is the hint. Next question. In the retrieval augmented generation process, what is the role of the vector database? Here are the options, and here is the hint. What is the maximum input capacity for both AWS Titan and OpenAI ADA as described in the text? Here are the options, and here is the hint. Why are vector embeddings considered essential for semantic search? Here are the options, and here is the hint. Next question. In the example provided, what is the final step after finding the closest vector in a database search? Here are the options, and here is the hint. Thank you for your time. Do view all the videos, solve the quiz, and keep learning and give the feedback in the comment. Thank you. See you in the next video.